Hi everyone, I am Angel Faith Neri Pasete.
Hi, I'm Rosina F. Suelo.
And I am Ruben Gilbert Manjola.
And we are the reporters of problem-solving heuristics, which is divided into cases and considering extreme cases. So now, we will be discussing another problem-solving heuristics. These are divide into cases and consider extreme cases. But before we undergo our lesson, we will know first our learning objectives. Our learning objectives are, at the end of the lesson, the learners will be able to break a problem into cases and consider extreme cases when appropriate. Second, modify a problem, look for symmetry or make it simpler. And the last one, explain the requirements of a problem and its solution. So, let's go to our topic. What is divide into cases? Divide into cases strategy, it is dividing the significant concentrations into small ones and then rules them. It is a partition of the statement into a group of smaller statements that together cover all of the original statement, then prove each of the smaller ones. And sometimes, if you divide your problem into a number of separate cases, based on a property of a subjects or objects appearing in the problem, it simplifies the problem and clear your mind. Diba? Sa tuwing nagsosolve tayo ng problem solvings, hindi naman natin ito na isolve agad. Kailangan natin ng mga strategies. So one of the strategies na pwede natin gamitin ay ang divide into cases. Para mas maintindihan pa ito ang mga examples. First, if 127 people play in a singles tennis tournament, prove that at the end of the tournament, the number of people who have played an odd number of games is even. So, ang hinahanap sa problem na ito ay ang dapat daw pagkatapos ng game ay ang mga odd number of games dapat ay maging even. So, the solution is many people unsuccessfully approach this problem by assuming that the tournament had a particular structure, such as double elimination or round robin or etc. But the problem doesn't specify this, di ba? Wala namang sinabi sa problem natin, kundi single tennis tournament lang. This implication is that no matter how the tournament is structured, the number of people who have played an odd number of games must be even. So the case number 1, for example, one possible tournament would be one where no one plays any games. Next case, then the number of people who have played an odd number of games is 0, which is even as required. There seem to be very few restrictions. Are they any? Mayroon ba? Yes. Each game has exactly 2 people playing in it. Siyempre single, dalawang tao, A at ang B. In other words, if A plays with B, then the game is counted twice. So kadalawa siya, twice siyempre, kadalawa. Once as part of A's count, and once as part of B's count. More precisely, if we let GI denote the number of games that the player I has played at the end of the tournament, then the sum G1 plus G2 plus G3 plus, or so on so forth, G1 27 must be even, since this sum counts every game that has been played exactly twice. Notice that the sum is always even, not just at the end of the tournament but at any time. So now we are done. The sum above is even and is a sum of an odd number 127 of elements. If an odd number of them were odd, the sum would not be even. So the number of GI that are odd is even. So, let's have another example. For every integer x, x squared minus x is even integer. So, may dalawang cases para ma-solve ito. Pwede x is odd or x is even, cover all integers. Case 1. X is even. X equals 2k for some integer k. X squared minus x equals 2k squared minus 2k equals 4k squared minus 2k. So, i-factor natin. 2 times 2k squared minus k. Amo na ng formula o yan na yung formula na kahit anong ilagay mo dyan, pag ilagay mo sa x squared minus x ay magiging even. So, yan na yung integer. Case 2. X is odd. X equals 2k plus 1 for some integer k. X squared minus x equals 2k plus 1 squared minus 2k plus 1. So, i-times natin or i-factor. 4k squared plus 4k plus 1 equals 2k plus 1. 4k squared plus 2k, or factor natin, 2 times 2k squared plus k. Na kahit anong ilagay mo dyan, pag na-solve mo, ay ang lalabas ay even pa rin. So, our next example. So, the furniture in a classroom consists of tables and chairs. The teacher is making a seating plan. If 2 students sit at each table, 8 students will be left without a place. If 3 students sit at each table, 4 tables will be left empty. How many students are there in the room? So, hindi naman natin alam kung ilan ang number of tables. So, the solution are, we will let x be the number of tables. So, yung case 1 natin doon ay mag-write tayo ng expression for the number of students when they sit in twos or by twos. So, magiging 2x plus yung left without a place na table which is 8. So, 2x plus 8. Yung first case natin. So, case 2, mag-write din tayo ng expression which is the number of students when they sit in threes or by threes. So, 3 times x minus 4. Pwede din 3x minus 4 yan. Kasi yung left empty ay 4. So, expressions in B and C both give the number of students. Thus, let's solve this. 3 times x minus 4 equals 2x plus 8. So, na-equate na natin silang dalawa para masolve natin ang number of tables. Masolve natin ang x. So, 3x minus 12 or 3 times 4 equals negative 12 equals 2x plus 8. Next, hindi na naman natin makakombine yung terms without like terms. So, i-like terms natin sila. I-transpose natin yung 12 dito sa kabila. So, 3x minus 2x equals 8 plus 12. So, we will now know our value of x or the number of tables which is 20. So, paano natin malalaman ang number of students? So, isa-substitute natin yung value ng x sa ating expression which is sa unang case which is by 2's na ang na-left ay 8. So, 2x plus 8. Yung x natin is 20, so 2 times 20 plus 8. 2 times 20 equals 40 plus 8 equals 48 students. So, pwede rin natin gamitin yung 3x minus 4, which is 3 times 20 minus 4. 20 minus 4 equals 16. 16 times 3 equals 48 students. So, same lang yung lalabas na answer. Pwede natin gamitin yung by 2's or by 3's. Therefore, there are 48 students in the classroom. Ngayon, alam na natin kung paano gamitin yung divide into cases na strategy. Lagi lang natin isa-isip o tandaan na sa pagsosolve ng problem, pwede natin itong hati-hatiin para hindi tayo mas mahirapan. Pwede natin gamitin ang divide into cases. Hindi natin siya isosolve ng pangkalahatan or general kasi mas mahihirapan tayo. Ang next na strategy na ituturo namin sa inyo ay ang consider extreme cases.
So let's talk about considering extreme cases. So, what is considering extreme cases strategy in problem solving? It is a type of considering a specific example. Here, the example is chosen to test the limits of a relevant parameter. Sometimes this gives insight into important processes. To analyze some situations, whether in a mathematical setting or not, it can be helpful to look at extreme cases. So, whether it is a mathematical a setting or in a reality, there are questions or there are problems that may look too difficult to solve. But kung titingin tayo sa mga extreme cases ng isang problem, it will be very helpful to solve such problem. So holding some variables constant while others vary to extremes sometimes yields useful insights into a given situation. Some problem can often be solved much more easily by considering extreme cases of the given situation. So by considering extremes, we may be changing variables in the problem, but only those that do not affect the actual problem situation. So also, we pose this situation in the context of a worst case scenario. That is, what is the worst that can happen if our argument goes awry? Then we proceed. This worst case scenario anticipation is a form of extreme case consideration. So, if you want to determine whether level of intelligence affects retention in a police force, you should consider officers with the highest and lowest intelligence on the force. If you want to determine how temperature affects the flow of electricity, consider a temperature of absolute 0. So let's have an example. Okay, I invite 10 couples to a party at my house. I ask everyone present, including my wife, how many people they shook hands with. It turns out that everyone questioned. I didn't question myself, of course. Shook hands with a different number of people. If we assume that no one shook hands with his or her partner, how many people did my wife shake hands with? I did not ask myself any question. So let's have an investigation. Kung titingnan natin, this problem seems intractable or very hard to deal with. Kasi walang enough information na ibinigay para ma-solve yung ating given problem. Nevertheless, we can make it easier by looking at simpler case where there are, say, 2 couples in addition to the host and hostess. The host discovered that of the 5 people he interrogated, there are 5 different handshake numbers. Since these numbers range from 0 to 4 inclusive, no one shakes with their partner. The 5 handshake numbers discovered are 0, 1, 2, 3, and 4. So let's call these people P0, P1, P2, P3, and P4 respectively, and let's draw a picture including the host in our diagram. So here's our illustration. So we're gonna label the host with letter H. So here. It is interesting to look at the 2 people with the extreme handshake numbers. That is P0 and P4. Consider P4 the least gregarious or the least sociable member of the party. He or she shook hands with no one. About uh, what about the most gregarious or the most sociable person, P4? P4 shakes hands with everyone possible kasi nga siya yung most gregarious person natin doon. So which means that everyone except for P4's partner shook P4's hand. So everyone who is not P4's partner has a non-zero handshake number. So P4 and P0 must be partners. At this point, we can relax for we have achieved the crux move or the most important point at the issue. Our instinct tells us that probably P3 and P1 are also partner. How can we prove this? Let's try to adapt the argument we just used. P3 shook hands with all but one person other than his or her partner. P1 shook hands with one person. So, do we have any more information? Yes. P4 was the one person that P1 shook hands with, and the one of the people that P3 shook hands with. In other words, if we exclude P4 and his or her partner, P0, then P1 and P3 play the role that P0 and P4 played. That is, they are respectively the least and most gregarious, and by the same reasoning, must be partners. So P3 shake hands with 2 out of the 3 people, P1, P2, and the host or H. And we know that P1 doesn't shake hands with P3. So the only possible person P3 can be partnered with is P1. Now we are done. For the only people left are P2 and H. They must be partners. So P2 is the hostess and she shakes hands with 2 people. It is easy to adapt this argument to the general case of n couples. Okay, let's have our formal solution. We shall use induction. For each positive integer n, define the statement Pn to be if the host invites n couples and if no one shakes hands with his or her partner and if each of the 2n plus 1 people interrogated by the host shook a different number of hands, then the hostess shook n hands. It is easy to check that P1 is true by drawing a diagram and working out the only logical possibility. We need to show that Pn implies P times n plus 1 and will be done. So, assume that Pn is true for some positive integer n. Now, consider a party with n plus 1 couples, so other than the host and hostess, satisfying the hypothesis no one shakes with their partners. All handshake numbers are different. Then, all handshake numbers from 0 to 2n plus 1 will be equal to 2n plus 2. Inclusive will occur among the 2n plus 3 people interrogated by the host. Consider the person X who shook the maximum number of 2n plus 2 hands. This person shook hands with all but 2 of the 2n plus 4 people at the party. Since no one shakes hands with themselves or their partner, X shook hands with everyone possible. So the only person who could be partnered with X had to have been the person Y, who shook 0 hands, for everyone else shook hands with X and is here ineligible as a partner. Now, let's remove Y and X or X and Y from the party. If we no longer count handshakes involving these 2 people, we are reduced to a party with n invited couples and everyone's handshakes number other than the host, about whom we have no information, has dropped by exactly 1. Since everyone shook hands with X and no one shook hands with Y, but the inductive hypothesis Pn tells us that the hostess at this abridged party shook n hands. But in reality, the hostess shook one more hand, that of the X whom we just removed. So in the party with n plus 1 invited guests, the hostess shook n plus 1 hands, establishing p times n plus 1. Okay, so often problems involve the extreme principle plus a particular argument style, such as contradiction or induction. May mga problems na masyadong mahirap, but using those extreme cases of the problem, it will be easier for us to solve it.
Consider extreme cases, example number 2. In a farm, there are 80 hens and 79 nest boxes to lay their eggs. At least how many nest box which has at least 2 hens? So, in a farm daw, meron 80 hens pero meron lang 79 na nest box na mapangintulugan nila. And the question is, how many nest box which has at least 2 hens? So, let us begin our investigation. The given is 80 hens and 79 nest boxes. The least number of nest boxes with at least 2 hens is being asked. Each hen of 79 hens lay their eggs on different nest boxes. So, there will be 1 hen left. So, we need to carry out the plan. Foremost, if each hen of 80 hens lay their eggs in 1 nest boxes, then 1 hen stays out and it have to lay eggs one of these 79 nest boxes. So there will be 1 nest box which has at least 2 hens. Diba merong 80 hens pero 79 nest boxes lang. Pag ang 79 na hens na yon mag-lay ng kanilang eggs through to the 79 nest boxes, meron matitirang isa. Then ang isang yon kailangan mag-lay ng eggs sa 79 nest boxes na napangitlugan na ng hens kanina. So, meron isang nest box na magkakaroon ng 2 hens. So, to check if our solution is correct, if we distribute 80 hens sa 79 nest boxes, then at least 1 nest box contains at least 1 hen. Hence, there is 1 hen in each box and totally 79 hens. But we have 80 hens, then the last hen have to lay their eggs in one of the nests. So, there are at least 1 nest box which has 2 hens. Consider extreme cases, example number 3. We need to solve this equation. X to the 4th plus x cubed plus x squared plus x plus 1 is equal to 0. So, let us investigate and find ways. While there are other ways to approaching this problem, we will use a symmetry of coefficient as a starting point to impose yet more symmetry on the degrees of terms. Simply divide by x squared. So if we divided by x squared to the equation x to the 4th plus x cubed plus x squared plus x plus 1 is equal to 0, the result will be x squared plus x plus 1 plus 1 over x plus 1 over x squared is equal to 0. This looks no simpler, but note now there is more symmetry, for we can collect like terms as follows. X squared plus 1 over x squared plus x plus 1 over x plus 1 is equal to 0. Now we make the substitution u is equal to x plus 1 over x. Note that u squared is equal to x squared plus 2 plus 1 over x squared. So, becomes u squared minus 2 plus u plus 1 is equal to 0, or 2 squared plus u minus 1 is equal to 0, which has solution u is equal to negative 1 positive negative square root of 5 over 2. Solving x plus 1 over x is equal to u, we can get x squared minus ux plus 1 is equal to 0, or we can x is equal to u positive negative square root of u squared minus 4 over 2. If we put this together, we can have x is equal to negative 1 positive negative square root of 5 over 2 positive negative square root of negative 1 positive negative square root of 5 over 2 squared minus 4 over 2. Then the result is equal to negative 1 positive negative square root of 5 positive negative I square root of 10 positive negative 2 square root of 5 over 4. The last step is mere technical details. The two cross moves were to increase the symmetry of the problem, then make the symmetrical substitution. U is equal to x plus x raised to negative 1. That's all, everyone. Thank you for watching this video. As a reminder, we already posted our quizzes and PowerPoint presentation through our Google Classroom. That's all. Keep safe, everyone, and God bless.